So in this video we're talking about laws of sines and areas of triangles. Now, we have a law, so this means it's very important that you make sure you have it memorized, okay? And what's nice about the law of sines and what we'll see in the next video, the law of cosines, is that we're still using sine and cosine like we did in the last chapter, but the last chapter was only right triangles. The law of sines works for any triangle provided you have the right conditions. Same thing for law of cosines. It works for any triangle provided you have the right conditions. So, law of sines. If triangle ABC has side lengths of A, B, and C shown, then this is true. The following proportion is true. Sine of A divided by side A is equal to sine of B divided by side of B, and the sine of C is over side C. So these three ratios are all equal to each other. So this is a rule you need to know. Now, you don't need all three of these. Essentially what you need is 2 out of the 3 ratios. That's what you need. So you can have A and C, A and B, or B and C. You've got to have 2 out of 3 to be able to make an equation. Okay, but all 3 of these ratios are equivalent. So in example 16, we want to solve this triangle, and we're told that angle C is 103 degrees, angle B is 28 degrees, and side B is 26 feet. So first off, I'm going to find angle A, because when it says solve the triangle, we essentially have to find all the missing information. So I'm going to start with angle A. The reason why I'm starting with angle A is because I know that for whatever type of triangle I have, the total angles always add up to 180. So we have 180 minus 103 minus 28, and that's going to be angle A. So I'm just going to use my calculator. Clear this out. 180 minus 103 minus 28. I get 49. So angle A is 49 degrees. I'm going to go ahead and put that in my picture. Now to find side A and side C, since this is obviously not a right triangle, I can't just do sine, cosine, tangent like I did in the last chapter. The only tool I have available to solve this triangle now is the law of sines. So what I'm going to do is just use my rule, and I'm going to kind of write it up here, plug in what I know. So I want to start by finding side A. I'm just going to go in alphabetical order. You do not have to go in alphabetical order unless you want to. So to do side A, I need to know angle A, which I have. So I have sine of 49 degrees over side A, and that's going to be equal to, well, I need to make an equation. And since I have an equation, I can only have one missing piece. So I need to use side B and angle B, because I've got both pieces there. So sine of B, which is 28 degrees, over side B, which is 26 degrees. So again, when you start off, you can only have one missing piece. And again, the law of sines, you only need 2 out of the 3 ratios to make your equation. Alright, so now what I want to do is get side A by itself. Okay? So to do that, what I'm going to do is, well, if I flip this fraction and I flip this fraction, they should still be equal to each other. Because since I have equal in the middle, that means the tops have to be equal to each other and the bottoms have to be equal to each other. So I'm going to flip my fraction. So, and this is perfectly valid. This is a nice trick. If you flip one, you have to flip the other one. So I have A over sine of 49 equals 26 over sine 28. Alright, so now that I flipped both of them, these 2 ratios are still equivalent. Again, if you flip one, you have to flip the other. And I want to get A by itself, so I'm going to multiply both sides by sine of 49 degrees. So I'm going to just come down here with that. So A is equal to the fraction 26 over sine of 28, and it's a fraction, so it goes in parentheses, times the sine of 49 degrees. Alright, so now I'm going to type this in my calculator and figure out what this is. Hopefully it's going to come out nice. First off, all my angles are in degrees, so I need to make sure I'm in degree mode. And now I'm going to say parentheses 26 divided by sine of 28, close parentheses, and then do the big parentheses. If you don't do all the parentheses, it's not going to come out correctly. Then times sine of 49 degrees, close parentheses again. I get 23.138. I'm going to round the 2 decimal places, so 23.14. And as always, I've said it many times before, the more decimal places you include, the better. So side A is 23.14. Okay. Now we need to set it up again, but this time we're going to find side C. So since I'm finding side C, I have to use angle C. So sine of 103 over C is equal to, now again, since I rounded side A, I don't want rounded, I want to know exactly. So the only thing I know for sure is exact is side B. So I'm going to use sine of B, which is 28 degrees. So sine of B is sine of 28 degrees all over side B, which is 26. Again, I'm using this because I know it's exact, and exact is always better than a round. Now, just like we did before, since I'm trying to solve for C, I don't like C on the bottom. So what I'm going to do instead is split both fractions. Now, this is totally fine as long as you remember to flip both. So C equals sine of 103. And that's equal to 26 over sine of 28. All right, great. So we went from that to this. Now I want to get C by itself. So what I'm going to do is multiply by sine of 103 degrees, which is going to be a nasty decimal, so I'm just going to leave it sine of 103 times this fraction. So what I end up with is C equals the fraction 26 divided by sine of 28 times sine of 103. Okay, and I'm still in degree mode, so I'm going to type this in my calculator exactly the way it looks with all the parentheses and everything. So I have parentheses 26 divided by sine of 28, close the parentheses twice, because that's what we did here, times the sine of 103. And I get about 53.96. Again, I'm going to go 2 decimal places. So we found all the missing sides, side A and side C. So 53.96. I like to fill in my picture. And I also found angle A. So I solved the triangle. It didn't have to be a right triangle because I used law of sines. Okay. Now here we want to solve triangle ABC. We're told that angle C is 122, side C is 18, and side A is 12. Again, solve the triangle means we just find all the missing pieces. This time, since I already have 2 of the sides, I'm going to go ahead and find side B. So again, the law of sines, let's write that out. I find that the more times you write out these rules, the more likely it is you're going to memorize it. So the law of sines is just sine of angle A divided by side A, which is equal to the sine of angle B divided by side B, which is equal to the sine of angle C divided by side C. Again, you only need 2 of these ratios to make your equation. And what you need, though, is an angle and a side. So that's what you're going to start with. So I'm just going to use this third ratio. I'm going to find side B, so I'm going to use the second and third ratios. So that's going to be my equation. So to set it up, I have sine. So actually, let's start with sine of A. I'm going to find angle A first to help me, okay? So, because I have side A. So you can only have one missing piece. So I have sine of angle A divided by 12, because that's A. And I have both pieces for sine C. So sine of 122 divided by side C, which is 18. Now, again, I have my equation. I only have one missing piece, angle A, so I'm good. Now what I want to do is, first step is to get sine of A by itself. Okay, I'm not solving for sine of A, but that is my first step, is to get that piece by itself. So what I need to do is to multiply both sides of my equation by 12. The 12s are going to cancel out on the left-hand side, and I'm just left with sine of angle A is equal to all of this mess. I'm going to go ahead and turn this into a decimal, okay? Now, since I'm turning it into a decimal, I'm rounding, so just keep that in mind. If you want to go ahead and just leave this alone, that's fine too, but it is kind of messy. I'm going to go ahead and round. Alright, so again, I'm in degree mode because that's what my angle is given in the original problem. So I have parentheses, sine of 122, close parentheses, divided by 18, close parentheses again, just like it's written, times 12. And I find that the sine of angle A is equal to about 5.57. Okay, I'm rounding to 2 decimal places. The more decimals you include, the better. Now, I don't want sine of angle A, I want angle A by itself. So I need to get rid of the sine on both sides. So what I'm going to do now is say sine inverse on both sides. So sine inverse of 0.57. So again, sine inverse and sine cancel out, and I'm left with angle A equals to sine inverse of 0.57. Again, I'm still in degree mode, so I'm going to type this in my calculator now. Alright, so second sine to get sine inverse of 0.57 is about 34.75. I'm going to go ahead and round to the nearest whole degree and call this angle A is about 35 degrees. Again, that's rounded, but that's okay. So I'm going to plug in my picture. Alright, now that I have two of my angles, I can go ahead and find the third angle, because we know that for any triangle, all the angles add up to 180 degrees. So 180 minus 122 minus 35. Use my calculator. (180) minus 22, or minus 122 minus 35. And that's 23. So my missing angle here is 23 degrees. Now, I still need to find side B. So to do that, I'm going to use the law of sines again. So side B, so I'm going to use this ratio, and I'm going to use what was given to me. So angle C and side C. So I'm going to use this ratio. So I'm going to set it up and do it in green. So I have sine of angle B, so sine of 23 degrees, which is the angle we just had found, divided by B, is equal to the sine of angle C, which is 122, divided by side C, which was 18. Okay, so now, like we did in the previous problem, I want to flip each fraction. So B over sine 23 is equal to 18 divided by sine of 122. Now I want to get B by itself by multiplying by the sine of 23 degrees. So when I do that, I have B is equal to my original fraction, 18 divided by sine of 122, times the sine of 23 degrees. Okay, that's kind of messy, but what we're going to do is type in our calculator exactly the way it looks. We're still in degree mode, so parentheses 18 divided by the sine of 122. Make sure you type it in right. Close the big parentheses, and then times the sine of 23 degrees. And we get about 8.29. Again, we're rounding. So we found all the missing sides. So yeah, it's a lot of work, but this is the only tool we have until the next video when we learn about the law of cosines. Law of sines is typically easier than law of cosines, so just keep that in mind. What we're going to move on now and talk about is the area of triangles, and this works for any triangle. Now, we all know by now that the area of a triangle is 1/2 base times height, but sometimes you don't have the base, or sometimes you don't have the height. So instead what you can do is use this new formula. And there's 3 ways to write it based on whatever pieces you're given. So for a triangle ABC, you can say 1/2 times the length of B times the length of C times the sine of A. Or 1/2 times the length of A times the length of C times the sine of B. Or 1/2 times the length of A times the length of B times the sine of C. It's all based on what information you're given in the problem. So let's move on. Do an example. In example 18, we want to find the area of triangle ABC. Well, I'm given angle A. I'm given angle A. So I'm going to go back to my rules. I'm finding, all right, here's angle A. So this is the rule I need to use. 1/2 BC sine of A. So that's what I'm going to use. So essentially what you need to do is, as soon as you know your angle, that means you're going to use your opposite 2 sides. So I know angle A, so that means I need to know side B and side C. Unfortunately, that information was already given to me. So now that I'm going to plug in, so I have area. Area is 1/2 of B, which is 5, times side C, which is 3, times the sine of angle A, which is 55 degrees. And so I'm going to use my calculator now and just type this in exactly the way it looks. When you do type it in, though, remember, every fraction has to be in parentheses for it to work. Okay? And I'm in degree mode because in my picture I had 55 degrees. So 1/2 times 5 times 3 times the sine of 55 degrees. And that'll give me my area of this triangle, which is about 6.14. So the area of this triangle is about 6.14 units squared. So again, this formula works no matter what type of triangle you have. And that's it for this video.